Hello students, we will once again continue with our study for a search for a new architecture. In this series, we are looking at the developments that are taking place in the 21st century vis-a-vis architecture in India. Last time we saw some works of Sanjay Puri and we saw how traditional knowledge systems are being married to contemporary technologies, and we are coming up with very amazing new ideas to use these traditional systems in our modern buildings today and to give us the best results, or rather very good results with regard to energy efficiency and thermal comfort, and that kind of modification is taking place. So we saw that through the works of Sanjay Puri, and one of the elements that we were discussing last time was the use of jalis and the use of courtyards, for example. So here in this slide you see this is a house called 18 Screens in Lucknow in 2019, designed by Sanjay Puri. This has both the courtyard and again it has got this jali work, which is also being designed computationally, just as it had been done for 72 screens, etc. Because this kind of arrangement of jalis simply cannot be done empirically. It requires a computational analysis to do it, and in this case the jali is also acting somewhat like a pergola to produce the glare coming from the top, and also allowing this perforation in the roof so that diffuse light comes through. Now he then brought this idea into this stone house in Nokha, which is still upcoming, with the use of traditional design materials, use of terraces and semi-open spaces and jalis to protect the building or the interiors from sandstorms. As you can see, this is typically traditional architecture, and this architecture has been brought in. We see that together with the modernist block form that you see here in this building. So again, it's a marriage of traditional architecture with modern architecture, something that is the basis of critical regionalism, but this is critical regionalism in the 21st century, where technology is playing a very important role. Now the adding of jalis or sun shading devices, courtyards, etc. is not done simply empirically but computationally. This is some of the other jalis that we see in modern Indian architecture today. So it's a vernacular or a traditional element in modern architecture. These are some other examples, and as we see, as you can see on the internet or read through literature, these kind of houses are coming all over the country, where use of exposed brick and concrete, use of traditional features like jalis and verandas and sun shading devices, etc. are being used by so many young architects in a much more methodical manner. One very iconic example is that of the Pearl Academy by Morphogenesis in 2008. This design was created to give an environmentally responsive passive habitat or a passive microclimatic conditions within the building, and it's a typical fusion of traditional building knowledge with contemporary cutting edge architecture. So the adverse climate that is there in the city is a challenge. It's a challenge to control the microclimate within the project, and to integrate the various passive climate control methods became a necessity in this hot and dry climate, and they were also required to reduce the dependence on energy intensive and mechanical devices. And therefore this modern adaptation of these traditional architectural elements and passive cooling strategies like open courtyards, water bodies, bowlies or step wells and jalis are all here. For example, here the water body that you see, and I will talk about it again in a little more detail, this leads to evaporative cooling, thus cooling the courtyards, and that cooled air then enters via the corridors, the singly loaded corridors as you see here, into the building. Moving ahead, this idea of this cutting edge interpretation of the jali that we saw in the 72 screens project last time, or when we see it in the Pearl Academy this time, this technological modification was also used by Stein in the India International Center. We've discussed this project earlier. Only difference is that the technical input into the traditional knowledge systems is growing with evolving technology, with simulation softwares, etc. So whereas this did serve its purpose quite well, these buildings are more efficient. And at a time in this in 21st century when this has become a critical issue for us to save energy and thus save carbon emissions. So the density of jalis used in the Pearl Academy has been developed using this computational shadow analysis based on the orientation of the facades, and it is completely wrapped around the building. So based on the facade, the jali has been designed computationally, and it is a complete envelope just as we saw in the 72 screens. The other thing is what was done in 72 screens also, that there is a gap between the outer wall and the jali, and this 4 feet gap from the building reduces the direct heat impact on the outer wall or the exterior wall. Moreover, the wind coming from outside passing through the jali, there is a condenser provided here which results in water vapor suspended in this area. There are drip channels, and this results in the breeze or the wind passing through the water vapor, leading to evaporative cooling, reducing the temperature of the incident wind on the exterior wall of the building. Now, the combination of jalis and water bodies were there also in Mughal buildings. For example, in Fatehpur Sikri, and it was a very simple principle that you have the jali, the wind flows through the small apertures of jali, the velocity of the wind increases, then it passes over the water body, enters into the singly loaded corridor or the veranda, and then into the interior, into the rooms, and thus the cool air flows into the rooms. So this was a process that they had used. Another example, which is the Emperor's Throne in Red Fort in New Delhi, where the throne has a water channel flowing underneath it. It's got these jali work around it, so the hot air passes through the jali. Then there is a grass mat underneath, and so this air cools down. Then there's a grass mat underneath the throne which is sprinkled with water. So that evaporative cooling takes place, and he is in a very confined microclimate of a cool area. Now, returning to the Pearl Academy, there are these self-shading courts and open stepped wells or bowlies that have been created to control the temperature of the internal space. The other important purpose of the courtyard is that it allows for this diffused daylight, not the glare of the sun, but diffused daylight which is needed for the studios and the classrooms to flow into them. So the entire building is raised on stilts or pilotis, and the raised underbelly creates a natural thermal sink because it is cooled by these water bodies that you see here, and this is, like I said, leads to evaporative cooling, and that cooled air then flows through the singly loaded corridors into the building. This is the section that is showing how the process of evaporative cooling is taking place. Another thing that they have done, and this is an idea that was also explored by Antonin Raymond in the Golconde Ashram, the first modernist building in India. If you remember, I told you that he had made these vaults on the top floor, on the roof of the building, and there was also a jali attached to the vault. Now, because of that, there was an air gap created because of this vault, and the sun rays, the radiations of the sun falling would not directly fall on the roof, but on the vault, and thus that would create an insulation, and those radiations would not penetrate the roof. As you know that maximum solar radiations penetrate in a building via the roof. So here also what the architects have done is they have taken a very traditional principle of using matkas. These matkas or earthen pots are placed upside down, and thus they create an air gap. And then they are filled, the space around it is filled with sand and broken bricks. Over this, a thin binding layer of concrete is cast. Because of this, when the sun rays fall, they have this air gap to contend with, and they are not. This creates a very good insulation layer between the roof and the this top the roof of the building, and then over that this layer. Now again, another idea that I would like you to recall is what has been used in the Sangat by B.V. Doshi, in which the barrel vaults, several things have happened. I'm just repeating that so as to you can recall those ideas. First of all, he's made a subterranean structure, and we'll look at another subterranean structure, but in a cold climate in this presentation. That is in what you would call a more of a composite or a hot condition, a tropical condition. So there, it's a subterranean structure, and then there is this barrel vault. The barrel vault has got these half terracotta cylinders. So after this has been cast in ferrous cement, then the half terracotta cylinders have been mounted on it. Then it is covered. Over that are the broken ceramic tiles or mosaic tiles, and that I told you is called, the process is called trincandis. That also appeared in the works of Antoni Gaudi at the end of the 19th century in the Art Nouveau movement in Europe. So many things are happening simultaneously. The subterranean structure is acting as a natural insulator. The thick earth all around it is acting as a natural insulator. Secondly, because of this barrel vault with these earthen, these half cylinders creates an air gap, and thus the radiations cannot go directly. Over that are the ceramic tiles which actually reflect back the radiation. So that is an added benefit. There are other things, for example, the water flowing on the side, there is a water channel flowing on the side, and that adds to the overall cooling down of the microclimate in the building, that is Sangat. So the sun also is not coming in directly, but between the barrel vaults there are these openings, and diffuse light falls into the subterranean studios. Another advantage they did was that they've cut it out on the side, so that can be used as a storage, because the walls became very thick being subterranean. I'm just recalling these ideas again, so you can connect all these ideas together. So the different architects are doing these different strategies. The only thing that is being added in the 21st century in this critical regional model or climate responsive building is the idea of computation, that everything is being assessed numerically, and everything is not done in a hit and trial manner, but it is assessed or simulated very clearly, and then it is executed on site. Now these traditional elements with cutting edge technology, the other things that we've used is energy efficiency has been a prime concern. So they are having 100% self-sufficient captive power along with 100% water supply, because they are using rainwater harvesting and they are also recycling wastewater. So these ideas are now becoming a regular feature in many buildings today. Institutional buildings particularly, corporate buildings are using these ideas to make their buildings more green or sustainable, energy efficient, passively comfortable. And even residential independent houses, there are a lot of clients who are very aware of these ideas. Of course, it is being used in residential projects, many of these ideas to reduce energy, we both embodied energy and operational energy, the ideas are being used. So this is something that you must focus on as a part of your study. It is not an area that you can neglect now. So this is the house I was talking about, where subterranean structure has been used in a cold climate. In Nainital, this is a house of Mohini Malik by Sanjay Prakash in a cold and cloudy area. It's traditional hill architecture. It's a load-bearing structure with a timber framed roof, and it is a very compact shape to reduce heat loss. The walls are made with thick random rubble masonry to increase thermal insulation and to preserve the heat inside, not let it go out. So just the opposite happens in cold climates versus hot climates or composite conditions, and that is, there we want to keep out the heat, here we want to retain the heat. So in both cases, insulation serves the purpose. In that case, it keeps out the heat, here it helps to retain the heat. So the entire roof is also insulated with rock wool. Now what is rock wool? Rock wool is made out of volcanic rock material like basalt or dolomite, and it is mixed with waste from iron ore, etc. So, lot of such slag, lot of such waste comes out from our industries, from our, I think, the steel plants, etc. And that waste is very damaging to the environment. So, what rock wool is created is that volcanic material. Now, volcanic rock is approximately 15% of the earth, the rock, the content. So, there that material is abundantly available. Along with that, this waste material is also abundantly available. So, that is combined together to create this insulating material called rock wool. So, that is being used here. So, the advantage is we are reducing waste by using it in this manner, we are recycling it, and thus and also we are serving the purpose of insulating the building. Now, the south orientation, this view that you see here actually shows you the south orientation, and here there is direct solar gain through these. So, the entire facade on this side is glazed to bring in maximum sunlight into the building. Now, see, the reverse is happening. There in hot conditions, I would go in for jalis, I would go in for sunshades and louvers, etc. to keep out the sun. Here it is fully glazed to bring in the sun. Now, this is similar to what happens in cold regions like Europe, for example, where right from the early part of the modern movement, they were using extensive glass. In fact, one of the great advantages of the developments that were brought in by Corbusier and Mies, etc., was this only, that they could have this entire facade free of load, and thus you could create it entirely of glass. You could have ribbon windows, you could have complete glass, and you could pull in as much amount of sunlight as you want to bring into the building. And this is what is happening here. Not only is it coming from the facade, the vertical facade, but even this part is inclined to pull in more sunlight into the building. Thus, the living area, the dining area, the kitchen area, which is the day use spaces, are on this side of the building, and this is on the upper floor of the building and day use spaces. Now, when we go to the lower floor, on the lower floor, what we find is towards the north side, it is sunk into the hill. So, here it is, the entire floor, this has got an earth cover on this side. So, that serves as a fantastic insulator. On the south side, where on the upper part, there was this glazing. On the lower part, we have the Trombe wall, which also serves for insulation. And you can read more about Trombe wall online. There is ample literature available for details of Trombe wall design and construction. And the entrance of the building is through an airlock from the north side. Airlock serves the purpose of a mechanism where the building is completely sealed at the point of the fenestration. I mean, in this case, a door, for example. And when we close the door, no heat can escape out of the building. Now, there is no opening other than that on the north side. So, also on the north side, he has provided the buffer spaces of lobby and staircases, etc., to add to the insulation. So, everything the architect is trying to do on the north side to increase insulation. The earth wall, the airlock, no fenestrations otherwise, and the buffer spaces are provided on that side. Also, renewable energy systems have been used, and they are using maximum of solar energy for thermal comfort, water heating and food warming, which is needed for a building like this. So, and in this part are the night use spaces like the bedrooms. Okay. Now, let's come to another building with a very strong concept of energy efficiency in a composite climate of Gurgaon, the American Institute of Indian Studies by Vinod Gupta. Here again, it is a part of critical regionalism with traditional Indian architecture and modernism. But the diverse spaces of traditional Indian buildings, gardens and courtyards and verandas and passages are all there, along with normal rooms. Now, the open and covered spaces are very significant in traditional Indian architecture because they help in controlling, in helping us to work along with the climatic conditions. But modern spaces are required for modern buildings, and that is a concept we've been repeatedly seeing, that we cannot do away with the modern part of these buildings because we need those buildings today. So here we have admin, research facilities and libraries, etc. So from the outset, the idea was that it should be an energy conserving and environmentally friendly building. Let me point out here also. This is again becoming more or less a necessity in lots of projects, including skyscrapers, which we will be, which you have seen before this. That we have talked about, for example, a skyscraper. We have talked about green concepts being used in skyscrapers. So here, the exposed brick finish is here. There are staggered walls which lead to mutual shading, as you can see here itself, that mutual shading is happening. Then the entrance, on the entrance it seems as if the building is single storied. But the interesting thing happens on the inside that actually it is double height space. So you go down as you enter in, there are sunken courtyards and the building turns into multiple floors. Now the orientation of the building is inclined 45 degrees to the side so that we could get a north-south orientation so that we could reduce the heat gain through the fenestrations or the windows. The courtyard's original function in traditional Indian architecture is for the purpose of bringing in light and to work to modify the climate. The internal climate can be controlled, cool down, for example, in hot conditions. So there are two sunken courtyards that have been provided, and you can see them in this picture. These are two sunken courtyards which bring in adequate daylight into all areas, including the basement. Because this is all sunken, so they are bringing in light deep into these areas, and small meetings can be held in these courtyards in summer. When I look at these spaces, I am drawn to them because of the greenery, the water, and the whole picture of being a very cool and shaded space. So the workspaces are arranged around these sunken courtyards, and the corridors work as a transition zone, because from the outdoor temperature that we see, we first come to this transition space of the corridor and then we go indoors. Now this is true for all buildings that have got courtyards and they have got corridors, and then they have rooms on one side. There is the courtyard, the corridor, and the room on the other side. So this is true for all of them, that in all of them the corridor serves as a transition zone. So there is no abrupt change of temperature from outside to inside. It is a transition. Then there is natural ventilation. The breezy central veranda brings in breeze which is suitable for the monsoon period. When I talk of the monsoon, I am reminded of the Kanchenjunga building, because there also they try to capture the breeze to pull it deep into the house. The way they designed the sky gardens, that is what it was intended to do. Now, why I am repeating these examples is so that you can connect the dots between these ideas being explored by different architects. The diagonal placement of the corridor helps in increasing air circulation within the building. Now there are the sun shading of the windows, and this is also very interesting how they do bring in daylighting. In the east-west face, because of the sharp sun they would get, they have these small slit-like windows, and these windows don't have normal glass, they have got glass bricks. So the light that filters in is a diffused light coming inside that you see here. It is not glare, it is diffused also, and heat also doesn't come in. Then we have light shelves. What are light shelves? Light shelves are basically sunshades over a window which have got ceramic tiles which have been laid on them. So what happens is that when the sun rays fall on this, they also create a ventilator here in the building. So when the sun rays fall on the sunshade, one is it prevents the sun rays from impinging on the window. That is the purpose of the sunshade. But the other thing they do is they reflect the sun rays back through the ventilator into the room like this. So as you see here, there is a light shelf on the outside, that is a sunshade which is layered with these ceramic tiles. That light is being reflected back on the inside, and you can see this lit up roof, ceiling, and that light is then lighting up the room. So no artificial light is needed during the day because of this process. Isn't it so interesting? Such a simple thing. Now please understand one thing, and I'll put a rider here. Light shades must be used very carefully. There are several designs for light shades that you will find online or in books, and they have to be very specific to the need that you have in a particular building, right? So because the pros and cons must be weighed, not only for this, but for all the technologies that I've talked about. It is not like if the technology is working in X building, it will definitely work in Y. They have to be balanced out, and how that will fit into the design or the problem that is in front of you. The terrace garden on this building is having these modern pavilions so that they can have large gatherings in winter. It's beautiful sun. But the other thing is, the terrace garden also serves to insulate. Because of this, it cools it prevents the sun rays from penetrating into the building. Now, there is also evaporative air cooling, which means, now it's only effective for 2 months, because, and why are they using the idea of evaporative air cooling? To reduce the overall air conditioning load. So what do they do? There are 2 stages in that. One is, so they've got these ducts laid along in the corridors, which are opening into the rooms, and this cooled air through evaporative cooling is pumped into the rooms, right? Ducts are carrying this cooled air, which are running along the corridors of the passages around the courtyards, and they blow the cooled air into the work areas. Now, how does it happen? First is, it is done with air which has been cooled by the addition of moisture. Now, I will not be able to describe the whole system to you. Even I need to have a deeper study of that, but I am only telling you the concept. The second idea is that the air is cooled indirectly by passing it over the heat exchanger of your system, and that is carrying cooled water, and this is not having any moisture content in it. Therefore, it is also, so we can do 2 things. We can have humidified cool air pumped in, or we can have dehumidified cooled air pumped in. It is possible to cool the rooms with some degree of humidity control. But active controls are needed. For example, in the archives, the temperature has to be maintained at 18 degrees Celsius. Therefore, air conditioning is needed. And there are other associated areas, for example, the library, where we need air conditioning. Thus, to reduce AC load in these areas where it is a necessity, these special places, library for example, are provided in the basement. Along with all this, solar water heating is also used for cafeteria and staff quarters. Now, I wouldn't directly put it in the slide for active control, because this is more a passive exercise. You're taking the sunlight and you are using that for heating purposes. So, predominantly the active control is associated with the air conditioning that they do, but there also they've been very sensitive in their design by providing the spaces that need this kind of air conditioning in the basement. Can you imagine that how much work has to be done on the design of the building also to be able to exercise all these passive controls? That is why I am repeating, by simply putting these passive devices will not solve the problem. A lot of architectural design effort has to be made into the overall design of the building, in the way the building overall form has been created, the way it has been oriented, the way the spaces have been laid out in the building. Every aspect of the building design is not only going to be governed by function, which is the predominant idea of modern architecture, form follows function. So function is the basic, the most important. But in this function has also been added the idea of energy efficiency, and along with that thermal comfort through passive means. So the function is not just restricted to basic functional layout, but these ideas have to work parallelly. That is why today we have teams working. We do not have a single person who is these consultants like we have structural consultants and we have interior designers and all pooling in their effort into the design of the building. These energy consultants, even seismic safety consultants, have to also come into the team right from the outset of the design. A very interesting building is also coming up in Gurgaon, again by Morphogenesis, and this company this firm is doing very interesting work with regard to passive design, and that is called the GYS Vision. It's not completed, it's still being constructed, and it is a stack of cuboidal volumes. Each cuboid is on a bungalow scale, and there are a set of attached open spaces with that cuboidal volume. Now, these open spaces in one of the three towers that you see here, this one tower that you see here is called the iconic tower. The iconic tower has got these sky gardens which are spiraling along the entire building. The other two towers are more what you might call muted, they are more regular, but they also have these system of proper climatic orientation, climate control, etc. And we look at those ideas. So here is the site strategy. Now everything has to be worked out. What is the site strategy? There is a central sunken court, and the towers have been so aligned or so put together that the sunken court falls into in a shadow zone, and thus a microclimate is created within the heart of the site, so much so that the assessment says that this will be a usable space even at 45 degrees Celsius in the afternoon as an outdoor public space. We'll wait and see, because it has not yet been completed. Auditing, the post-occupancy audit has not been done, but this is the idea that has been mentioned. Okay. Now the office blocks are oriented north-south to allow daylight to penetrate into the building and reduce the dependence on artificial lighting. Very standard idea that is explored here. And as you can see, there are these louvers that have been horizontal louvers and vertical louvers that have been provided, for example, on the north elevation. But on the west, it's only small punctures that have been given. When I look at this, I'm reminded of a design of a house called Maison Bordeaux by Rem Koolhaas, where he had created a mass. You can look at those pictures. It's just a visual comparison. I'm not talking in terms of the climatic impact. Now, the facade design is orientation sensitive and plays an important role in creating the built volumes. And for example, the iconic tower, every third floor plate is approximately 1200 square meters, and out of that there is a double height sky garden which is approximately 450 square meters. So here it is, this floor, this is the floor, and then you have the sky garden which is attached to it, as you can see here. Then the identical towers, the two other towers, they have their facades which are focused to reduce solar gain while providing maximum view. So what they do is that the service core is provided on the southwest side here, where we would be getting the maximum hot sun as the sun moves towards the late afternoon and early evening time, and therefore that sun is completely blocked, and then we are getting these views on this side. So that is the way the entire organization of the plan has been done, keeping this climatic control in mind. This is how the sky gardens would look. These are some of the views of the sky garden. This much part I believe has already been constructed. This is the sunken courtyard, and these are the views of this is what the sky gardens would look. So there are a series of stepped sky gardens throughout the building, and this is how the rotation of the volumes has been done. So we can read this slide, how the massing has been done in the iconic tower, and the step gardens have been created. Now there is also this slide actually indicates the amount of background work that is being done to make the buildings thermally comfortable. Insulation analysis. What is it? It just talks about the amount of solar radiation that are penetrating into the building. So what is the analysis showing us? That if we have the south elevation without the shading devices, then the amount of insulation is in watt hours. As you can see, the color is red, so it will be somewhere in this zone, right? But with the shading devices, the insulation decreases to somewhere in this zone. Similarly, on the east elevation, again, you find that without the devices, it's on this higher range, and then with the devices, it comes down in this range. So this is showing that the design of the insulation devices has played a very important role in reducing insulation or solar radiation penetration. Now, the idea of the sky garden is not unique to the GYS vision. The same idea was earlier explored in the Commerce Bank in Frankfurt by Norman Foster. We see these sky gardens spiraling up the building, and then the same idea was again explored by Norman Foster in the Swiss Re or the Golconde in London. So this has these internal, not actually gardens, but there's an atrium and there are these spaces within that work as outdoor spaces, and the entire building is encased, and along this, did you see, is where those outdoor those spaces have been created. You can walk out of your offices and be in that area. Then of course the idea of the terrace gardens is there in the Kanchenjunga building, where Charles Correa has used the idea. The idea of these sky gardens is also there in the interior, that is Mr. Mukesh Ambani's house, and you find that at a higher level, I believe somewhere here, forgive me, here we have the sky garden, right? And so that is another example. This is putting the sky gardens together. This was what I was talking about in the Swiss Re building, the outdoor hangout space within the overall glass volume of the building. This is the GYS Vision Sky Garden, this is in Commerce Bank, and this is the Kanchenjunga apartments. Now there is another idea with regard to groundwater harvesting. In GYS Vision, the underground water stream turned out to be a construction challenge. The standard structural solution was prone to failure when the water receded. So therefore, they came up with an innovative groundwater harvesting system. They have used an under-slab drainage system. The net water harvested through this groundwater system is about 600 liters per day of raw water supply, and they have been awarded the GRIA Award for exemplary practice recognition for passive architectural features for this building. Now please understand that this building is yet to be completed, but already the practices used by the architects in the building have been adequately recognized and rewarded. There are other buildings also that fall within the category of critical regionalism, where all these ideas of thermal comfort, etc. are explored, and I'll just give you a list of few of them. National Institute of Faith Leadership in Dasna by RCOM in 2014, the Institute of Engineering and Technology in Ahmedabad University by Will Muller Architects in 2015, the Kumar Resort in Almora by Zova Architects in 2017, the Buddhist School in Bangalore by Chitra Vishwanath in 2014, the Indian Naval Academy in Kannur by Satnam and Amita Singh in 2009, the Pavapuri Guest House in Rajasthan by Matharu Associates in 2009. Now, if all these buildings, if I take you back again, what I would like you to focus on for a minute is where these buildings are located. This is in UP, composite climate, composite hot climate Ahmedabad, cold climate Almora, hot tropical climate Bangalore, it's much more comfortable climate, Kannur, Kerala, hot and humid, Rajasthan, hot and dry. So what you find here is that all these different projects are spread all over the country in different climatic zones, and each one has a different climatic response. Now when I keep on repeating the idea of thermal comfort, energy efficiency, climatic response, please do not read into my statements the idea that I am neglecting the point of design. I am not at all neglecting that. In fact, I am reinforcing that. And how am I reinforcing that? What I mentioned earlier to you. Active control buildings are much easier to design. All I need is, because my building is actively controlled, I do not have to play much with the form, because I am not constrained by the form at all. My form will not contribute to the conditioning of the building. The systems will do that. The mechanical conditioning systems will do that. I can raise a tall building, I can make it surrounded with sleek glass and fantastic looking materials and look very beautiful, very attractive. very even posh. But these buildings require a huge amount of effort because the built form plays a very important role in the climatic control. And not only that, remember the Vitruvian triad I talked about earlier, form, function, structure. No building, I repeat, no building can succeed without good aesthetics, without a good and attractive form, without a very functionally well working space, and of course a safe and sound structural system. We'll end here. Thank you so much for joining in this presentation. We have 2 more presentations left with regard to a search for a new architecture, and I hope to see you next time. Thank you.